Storing data at AWS requires a high level of data security. Let's take a look at the different options that are available at every level of data once we store it at AWS. When we're looking at the overall flow of data security, we have a start-end life cycle to consider for all data. How long is it stored? Is it encrypted? Is it deleted after a period of time? Is it held forever? How many copies of data are actually stored in the cloud? So we have to consider the start-end life cycle. You might have temporary storage of data in the cloud. That's also important to consider because maybe you forget about it. What I've found is that when you store data in the cloud, you tend to forget about it because it's not on-prem. It's just something that you've stored. With anything that I do, with any service that I use at AWS, I want to be monitoring what I actually use, i.e. the services, at AWS. Only by monitoring can I figure out if there's an issue. Data security monitoring might be monitoring that checks as to who actually accesses the content. Did somebody try to access the content that they're not allowed to actually access? All forms of data security at AWS offer data encryption. Now, data encryption is not enabled by default for most services. It is enabled if you're archiving data with S3 Glacier. Other than that option, you have to turn on the data security, but it is available. And the concept of redundancy and durability really applies when you think of data security at AWS. You don't have anything just stored in a single virtual hard drive. You always have redundancy. You always have multiple copies. In a sense, the cloud security for data is much more available, much higher level than what we can do on-prem. We can easily store a file on-prem on a single memory stick. In the cloud, there's always multiple copies. The access to data is, of course, the important aspect. What is accessing the content? It could be an application. It could be the end user. The infrastructure, i.e. the load balancers or the compute and the storage platform, the virtual hard drives, that's supplied by AWS as a service. You, the customer, selects and manages the access to that data, i.e. the endpoint. Is it a public endpoint? Is it private? The customer has to manage the data access. Amazon will provide security. The customer can mess it up by making the data publicly accessible when they didn't mean to do that. But that's our role. That's our job. There are many protections for our data that can be utilized by using additional services. If I use a load balancer in front of my applications that are hosted on EC2 instances, I am protecting access to those instances because all access has to go through the load balancer before it can access the instances. So we have an extra level of protection. If I'm using cached content for my applications using something like CloudFront, another service that sits in front of any data that has been made public facing. What I mean by a different level of protection of our data when we're looking at either load balancing or CloudFront is that these are services that are running on massive server farms, and they don't accept malformed packets or malformed requests. So if either of the load balancing service or CloudFront ends up being under attack, say a DDoS attack, because they're a monitored service, they can scale up and try to avoid the issues of being attacked. So we have some interesting levels of protection by utilizing additional services. In addition, if I store data on a virtual hard drive, I'm using the Elastic Block Storage Service, that's EBS. When I store it on a virtual hard drive, behind the scenes, Amazon replicates multiple copies within the availability zone, specifically within the data center where that virtual hard drive is located. Speaking of EBS data volumes, what happens as far as the level of security when a drive has been discarded and somebody else wants to use that drive? What Amazon does is it protects and cleans the drive just before it's available for use to ensure that they're not handing off virtual hard drives that have old content still stored on those volumes. The customer decides the file system to be created on the EBS volume. That's either Windows or Linux. And the access to this service when creating the file system is going to be restricted to the AWS account that ordered that EBS volume and the users, the IAM users that have been granted access. Remember, if you don't have access, you don't get to use the service. An additional level of protection of anything that I create on an EBS volume is that I can create a snapshot, a copy of the records, and that is stored in another location, specifically in S3 storage. So lots of levels of protection here, from starting with a brand new drive, who gets to access it, and the protection with a snapshot. If I'm looking at additional protection for S3 buckets, and an S3 bucket is an amount of cloud storage that's unlimited, and S3 buckets can be made public so anybody can access that content across the internet. What you can also do with an S3 bucket is you can enable something called OAI. That's Origin Access Identity. This is a special user. Think of it like a robot. And once you enable this, the Origin Access Identity is the only way that content can be pulled from that bucket for an end user. So we're protecting direct access to the bucket using OAI to restrict direct access to the bucket contents. We've talked about encryption, and Amazon has the key management service that integrates with all data services. So if you need to encrypt an S3 bucket, if you need to encrypt a virtual hard drive, it's very easy to enable the process of providing data encryption keys. When we look at the levels of compliance that are offered by Amazon, we've got a lot of possibilities here that will match up with the compliance levels that you have to follow. Most compliance levels want multiple copies of data. Well, availability zones store EBS data volume backups with multiple copies of data. The regions and availability zones where you store your data, specifically S3 buckets, well, there's multiple copies of all files in S3 buckets. The Elastic File System, multiple copies of the data again. FSX, storage for Windows servers, multiple copies of the data automatically. And RDS databases, multiple copies of the database records with multiple storage locations, i.e., multiple availability zones. Amazon has this level of storage to match with your compliance levels. You also might have issues with sharing in the cloud, but it's pretty hard to run in the cloud without having some sharing. But perhaps your compliance levels say, I can't share my compute. So what I can do within my network locations at AWS, that's the VPC, the virtual private cloud, I can change or control the tenancy of the compute resources that are stored on my networks. I can say either shared or non-shared EC2 instances. It just depends on your compliance level, what you're trying to achieve. The types of network connections that I can utilize to match the compliance levels of what I need in order to operate in the cloud can either be an HTTP or HTTPS endpoint. You can also use private VPN connections. And as talked about, only S3 Glacier has encryption enabled and mandatory by default, but I can turn on data encryption for any data records that are stored at AWS. When we look at the levels of data encryption, S3 buckets, AES 256-bit encryption, I can enable it. RDS databases, depending on the flavor of database that you choose, there are a variety of encryption choices available. EBS volumes can be encrypted. The shared storage arrays, either EFS and FSX, also support AES 256-bit encryption. And customers can also utilize what's called client-side encryption. meaning that you encrypt it first and then you move the records up to AWS. That's kind of a foolproof way to encrypt things. You hold the keys. Amazon doesn't even have the keys. Finally, it's important to remember that any logs that I'm utilizing, they're data as well. And there is lots of logging that can go on. If I have what's called a trail when I'm using CloudTrail, that is a record of accessibility, what has happened in my AWS account. Those trails can be stored in S3 buckets. If they can be stored in S3 buckets, they can be encrypted. CloudWatch, the monitoring service, has logs of information. Those logs of information can be stored either within the CloudWatch logging service itself, or they can be stored in S3 buckets. You may be thinking, why always S3 buckets? Well, remember, S3 buckets have unlimited storage. You can't run out of storage. If I'm using an ELB load balancer, the logs can be enabled to track all the traffic from that load balancer. If I have networks, specifically VPC networks, I can enable what's called a flow log and capture the flow of network traffic throughout my networks. If I'm using S3 for storing resources, I can have logs as to the access to the buckets themselves and what was carried out, what process, whether it was deleted, whether it was put, whether it was moved. I've got a lot of information that can track what has happened within my data resources. So I can get a lot of information as to what's going well and not going well with all of my storage at AWS.